Hello everyone. So in this video we are going to look about how to find the higher moments, and to find higher moments of a specific distribution it is required to know how to do the integration of that specific PDF that is being given with. So firstly, as I have already told in the previous videos, higher moments what they do mean is e of x to the power n, right, for some natural number n. So it could be x squared, x cube, x to the power 4, and so on and so forth. So we are trying to figure out how to find this for any general n, and for this, as you know from the definition, that we need to understand how to do the integration for those things. So it's gonna be a while we look forward into the details of what to do and how to do them. So let me first quickly write down the PDF for the exponential distribution. So x is distributed with exponential of lambda, and f of x is lambda into e to the power minus lambda x, where x is greater than 0, and we want to find the following. And as we know, we can manipulate this because the PDF is not defined in the region which is minus infinity to 0, so we can manipulate it as follows to get the following resulting integral. So this is the resulting integral that we need to find in order to find the moment, that is the nth power, the nth moment of an exponential distribution. So what I did here was basically I separated the limits of integration into two different regions, that is minus infinity to 0 and 0 to infinity, and I took advantage of the fact that the PDF is only defined in 0 to infinity and it is 0 otherwise. So integration of a 0 variable, no matter the limits, is always 0. So we do not even need to look at the limits. If the function is identically 0, it is 0. So the resulting answer is we need to find the integration for 0 to infinity x to the power n f of x dx. Now we come to the crucial part of the problem, which is the calculation. So first let me just write it down. So as you can see, e of x to the power n is 0 to infinity x to the power n f of x dx from this line. Then we put in the value of f of x, which is lambda into e to the power minus lambda x. And as lambda is a constant, what we can do is we can take the lambda outside and we can write lambda into 0 to infinity e to the power minus lambda x into x to the power n dx. Now let us name this integral as I of n. So we just keep the lambda as a constant and we will try to find it in terms of n, right? Okay, so let's go. In is equals to 0 to infinity x to the power n e to the power minus lambda x. So I'll tell you exactly how to find this, and notice that n is a natural number. Okay, one special value is I of 0 should be equals to 0 to infinity x to the power 0 e to the power minus lambda x dx. That is 0 to infinity e to the power minus lambda x dx. And as we all know, this would evaluate to the following. This we have done multiple times. This is just 1 by lambda, right? Okay, so now let us find out how do we evaluate this integral. So what I will do is I will explain it later, but for now we can understand that I'm going to do integration by parts, with the first function as x to the power n and the second function as e to the power minus lambda x. So this part becomes, this is the limit that we will show that it is equal to 0, and for this one we see n into x to the power n minus 1 e to the power minus lambda x dx, right? Now this would be 0, which we can show later, and it will be n by lambda 0 to infinity x to the power n minus 1 into e to the power minus lambda x dx, right? So this parts I hope were clear, but no explanation is required because we have done it before in the when we had found the second moment. Now this became n by lambda, and as you can see this is just I into n minus I of n minus 1, right? So what we can conclude is I of n is basically n by lambda into I of n minus 1. Now in a similar way this should be n by lambda into n minus 1 by lambda into I of n minus 2, and this would be, so for 2 it is this, for n it would be all the way up to n minus 1, and there would be like lambda to the power n I0. This would give you n factorial by lambda to the power n into 1 by lambda. Therefore we can see that the answer here is basically e of x to the power n would be equals to lambda into in, which is lambda into n factorial by lambda to the power n plus 1, which is n factorial by lambda to the power n, which is the answer. This completes our question. So anyways, in the next video we shall see about the MGF. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.